Hey, what is up everyone? Welcome back to another video. In this video, we're going to take off our usual hacking hat and we're going to join the blue team. Well, maybe more of the purple team, the way that we approach this lab, but we are going to do some threat hunting in the cloud in AWS using the ELK Stack. So we're in Pwned Labs. If you've never heard of Pwned Labs, you need to check it out. Pwned Labs, in my opinion, is the best platform for learning hands-on cloud security. They have labs for both blue team and red team that cover Azure, AWS, and GCP. They have over 30 completely free labs. No subscription, no money needed for those 30 free labs. But if you do get a premium subscription, it is only $200 a year, which is incredibly affordable compared to other platforms. And for the $200 a year, you get access to all of the premium content, including Thunderdome, which is going to be coming out this month. Thunderdome is a red team cloud pen testing lab that covers AWS, GCP, Azure, in one large, massive, realistic environment. So I'm pumped to do that. I do have early access to it, so I can tell you guys from my own experience, Thunderdome is amazing. But in today's lab, we're going to work through this one, detect threats in the cloud with ELK Stack, a blue team AWS lab. And I do have to say this one is a premium lab. So you cannot follow along unless you have a premium sub to Pwned Labs. But hey, if you don't have one, you should go get one today. If you don't have one though, I will show you the entire lab, the entire walkthrough to give you a feel for what these labs are like. And the other resource I want to recommend, we're going to be doing a lot with the ELK Stack. And one learning path that's been helpful for me comes from TryHackMe. So if some of this stuff is completely new to you, I recommend the SOC Pass on TryHackMe, but ELK in particular, they have a really excellent module on advanced ELK where you learn about the main components of the ELK stack by going through the installation, configuring processes, and linking them together. As you can see, I've done it. I've done most of the SOC 2 path, but if you're a little bit lost as we work through some of this ELK stuff, I'll do my best to explain it, but once again, I would recommend this pathway in TryHackMe to give you a good, solid foundation on some of this blue team log analysis type things. But what we need to do now is I'm actually going to share my face for just a moment because let's get our notes pulled up. I don't know if we will have anything we take notes on for sure since it's more blue team, but we'll give it a shot. We'll at least start area for it. So we'll go to labs and boxes, and I'm using Notion right now for my notes, and we will create a new note and we will just copy the name of this lab. Detect threats in the cloud with ELK Stack. There we go. And I like mine being full width. And I also like to be able to tab back and forth. All right, there we go. So detect threats in the cloud with ELK Stack. We have our ELK Stack URL, so we might want to grab that for our notes. And we'll just paste that in there at the top so we have it. Default sec said, I'm lost for the most part on any Pwned Labs machines. Yeah, cloud can be super confusing, especially AWS. Like, I think Azure's a little easier to understand. AWS uses the strangest names for everything, and just the syntax doesn't make a whole lot of sense. I always feel lost, especially when I was first learning cloud, but the best way to get your handle on it is you just have to put in the time and put in the work. The nice thing about Pwned Labs is every single lab has a full detailed walkthrough, and many of the labs now have me working through them on video. So hopefully you find those helpful, and I'll do my best as we go through this to explain things that might be a little bit confusing on the cloud side of things. But we have our URL there. First, let me just make sure I can connect to it, and I can. Okay, beautiful. And actually, I want to do it on my other tab. So I'm just going to copy that, switch to my other tab, and we'll pull up the ELK Stack there. So let's understand our scenario. After noticing unusually high CPU usage on an EC2 instance, someone get a crypto miner? You have decided to investigate recent AWS CloudTrail logs using ELK Stack. Your mission is to identify if there are any unusual activities or anomalies that would be causing this. So let's go ahead and grab that, and we will go ahead and do scenario. If I can spell, there we go. So there is our scenario. I'll also zoom in a little bit on this, and let's see what other information we have. So we have our lab prerequisites. This is an understanding of what we need to do. Basic experience with log analysis. Once again, if you don't do that, I recommend that TryHackMe learning path or module really on using ELK Stack. And honestly, both the SOC 1 and SOC 2 learning paths on TryHackMe are really good for this kind of thing. But to be clear, y'all, I am not a blue teamer for my day job. And I don't even play one on TV. I sometimes play one on Twitch, but this definitely is not a strength of mine, which is one of the reasons why I'm doing it. I'm trying to get better at blue team, incident response, things along those lines. Hey, looking over at YouTube, say hello to a few more people jumping in. We got Nox Lumens, MW, Zach. What is up, y'all? Thank you for hanging out here. And also, we have IT Professional, a beautiful name, Nefos, Default Sec. I think I already said hi to you over on the Twitch side of things. But here's what we need. Basic experience with log analysis, foundational security knowledge, foundational AWS knowledge, and familiarity with the AWS CLI. Now, if you don't have any of that, that's totally okay. The point of this video is to guide you through some of this. So let's understand what are our learning outcomes from working through this lab. Well, number one, know how to set up and configure ELK Stack, import data into ELK Stack and resolve import issues, identify and track malicious activity, and use ELK Stack to piece together a timeline of events in a breach, and get familiar with common AWS offensive tooling. Now, a lot of Pwned labs will tell you, hey, this is suitable for a CTF approach, or it's not suitable for a CTF approach. And we can see this one is not suitable for a CTF approach, but we're still going to try to treat it like a CTF. So we'll read through some of the introductory information, but once we get to the more challenged part, we'll try it on our own and we'll go back and forth to see if we can figure it out together. So real world context, ELK Stack is a free and widely used tool that is very powerful. It allows defenders to accurately tell the story of what happened in a compromise or a security incident. So walkthrough, the hands-on aspect in the lab starts in the hunting section. Okay, good to keep in mind. All the logs for this lab have already been imported. For those interested in setting up their own ELK Stack instance, instructions are provided below. For the sake of time, we are not going to do that on our own, but I bet you could set it up with Docker, maybe. Like, oh yeah, there you go. You could probably spin it up pretty easily with Docker if you want to do this on your own. There's also another good lab on TryHackMe. I think it's called Fix It, and it's with Splunk though. I don't think it's with ELK Stack, although I could be wrong. I have a YouTube video of me working through it live, but it really teaches you the importance of importing logs and then fixing errors. That's the whole goal of that lab. You have to fix different importing errors. So another lab to check out to get more experience with those kinds of things. So setup. After installing Elastic, starting the service and setting it to run on startup, we navigate to port 5601. We see the page below. All right, there's our page. Actually, I'll drop this to its own, but there's our page. There's no authentication or default creds out of the box, right? So that's a security thing. If you don't finish setting up ELK Stack and you import sensitive data in there, not a good idea, right? Checking on add integrations, we see a huge number of log sources. Feel free to play around and explore, which I'm going to explore by looking at the screenshots because I'm not going to set that all up on my own right now. For this lab, we've already collected the CloudTrail logs of the incident and imported them. We'll go through this process quickly now before getting our hands dirty. So although we're not going to do it ourselves, let's see if we can understand what is going on. So when you open up integrations, you can see all the different things you can import, and we are working with this right here, AWS CloudTrail logs. First, we need to enable security on the Elasticsearch instance. Probably a good idea. You don't want to import data without first adding a password to it. And so that's what we're doing here. We are dealing with security events and they are sensitive in nature, just like what I said. So we don't want someone getting access to the server without logging in first. With SSH access to the server, we add these values. So we're enabling XPack security and an API key. Then we run this command to generate various ELK Stack passwords. I believe these are all randomly generated as well. I don't think there's default passwords. So when you run that, it gives you those randomly generated passwords. Then we update the YAML file with the Kibana system credentials, which I think we got from up here. So you add that to the Kibana.yaml. After restarting the services, we could log into the provided URL with Elastic and that password. So let's go ahead and give that a shot and see if our stuff is properly configured. And so far, so good. The next step is to make the collected logs ready for ingestion. Note, the log data has already been imported into your ELK Stack instance. Thank you for that. The CloudTrail logs needed a few changes before importing, which they often do. This is a big thing to know. Anyone who works in a SOC, works on Blue Team, you know this better than I do, but logs don't usually play nice the first try. You need to be able to manipulate them, find errors, and troubleshoot them. So for this, we used a helper script to include in the SOC ELK repo created by Phil Hagen. Let's actually check out this script and see what it's doing. This script will recursively read a file or directory tree of JSON AWS CloudTrail logs and output in a format that ELK can read. Both gzip and native JSON is supported. I see. So it's just making it so it can read the data. It takes a few different arguments, read, write, force, append, and it's just making the changes so it's easier. Like you don't have to manually get everything ready. Running the command below, we create a single JSON file that contains all the CloudTrail logs. So we are passing it, was it file and R? So file, force and read is what they're doing. So force and read, we're giving it our S3 logs, and then we're giving it to a JSON file. So then we can then upload this JSON file to the ELK stack. After navigating back to the login page and clicking explore on my own, we see the page below. This allows us to upload a file. Right there, upload a file. After clicking that and uploading ready to ingest, we see the summary below. And this is where it probably errors out. After clicking import, we choose the simple import option below and click import again. The import completed, but we encounter some errors. Always, that's the thing that frustrates me on the SOC side of things. So for those of you who do blue team for a living, you're my hero. It's a lot more difficult than people think, even just getting logs to import properly. We see that the IP value is malformed for some reason. Of course it is. We import the data again, but this time choose advanced and name the new index AWS 2. So AWS 2 must be what we are working with. If I go to discover and change it to AWS 2, that's going to be what we're working with. AWS 1 is the error. Then in the mapping section, we located source IP and added ignore malform true. So we ended up with the below. So almost like a try except thing. Okay. And then they imported it again. All right, hunting. This is where we start. This is where the hands-on portion starts. And I just need to know the time frame, and we'll go from there. Log into the provided URL if you haven't already with the username Elastic and that password, which we have. From the drop-down, okay, I already did that. Select AWS 2 from the drop-down menu. And maybe I should explain what we're doing here. AWS 2 is kind of our source. AWS 1 is the one with the errors. So when you import logs into ELK Stack, depending on where they're all coming from, they will have different names like this. So that's all I'm doing right there is selecting the right log data, the one that was imported above that isn't broken with the malformed IP addresses. So we're doing AWS 2. By default, the time range is 15 minutes, so it doesn't have any data to display. Okay, so here is where we're starting out at, and we'll try to do some of the lab ourselves from here and see if we can investigate what happened. So February 25th, 2024, let's jump back over to our Elastic instance, and actually not that, we'll go here, and we want to change this to an absolute date, and then we'll update our start date down there, and we will just click update, and sweet, we do see some data. And let's go ahead and remind ourselves, what is the context? So we notice unusually high CPU usage on an EC2 instance. It should tell us the EC2 instance, but I suppose it's not made for a CTF. I'm treating it like a CTF, but we know it's an EC2 instance. We've decided to investigate. Our mission is to identify if there are any unusual activities or anomalies that could be causing this. So that sounds good. We can see we have a couple of days here. We have February 25th and February 26th. We have a bunch of events on February 26th, so I'm just going to click in there first. And we see some spikes of activity. What we need to do, though, in order to make this helpful, is we need to sort the columns or fields. I think fields is the right thing. The fields that might be most helpful to us. We have some suggestions here on the side, and I'll show you how this works. Hopefully you can see it okay. I know it might be helpful if I zoom in, but if I zoom in, it's hard to read all the fields. So I'm going to keep it zoomed out like this. But I think some fields that might be helpful to us, one would be source IP address, so we can see the source IP of whatever action is happening. The other one might be maybe user agent, and maybe the access key ID, and maybe user identity as well, so we can see like which user is doing this within AWS. CID. Let me look at one of these logs. This is another way you can do it. We'll just look at one of these logs and let's see what other information might be helpful for us. So we have additional event data. Oh, you know what else I forgot, guys? We can't hack without our hacking candle. I told you, for those of you on stream last night, like some streamers drink coffee, I like candles. So I have a strange personality. But I told you guys on stream last night, I burned like all my candles out. I needed new candles. So look what we got. cooking today. We got, I don't know if you guys can see it in my bottom corner, but today's hacking candle is warm apple pie from the very sophisticated store of Dollar General. So let's go ahead and light up our candle. Oh, come on. There we go. Hopefully you guys can see it. We got our candle lit up. Hopefully pretty soon it will start smelling like warm apple pie. I don't think you guys will be able to smell it, but you'll just have to live in the moment with me and pretend like you can smell the peaceful warm apple pie. Region might be helpful, although I don't know if it'll be super helpful for right now as we do the investigation. Event category, event source, event type might be helpful. We know kind of what's going on. I'm going to go ahead and grab that. We don't want to filter for value. We want to just add it. So we'll do event type. And let's see if there's anything else interesting. Bucket name may be helpful. Oh, so that's the malformed. The source IP for this, it says CloudTrail, and ELK Stack is like, bro, that's not an IP. What are you talking about? Let's look at another command. Like, let's look at this one, because depending on the command, there might be different fields that we want to grab. Do I have event name? Event name might be helpful as well. So let's do that. Event name. Whoops. Event name. I don't know if request parameters would be helpful or not. For now, we'll leave it. We already have user agent. I think we already have access key ID. We probably don't need the account ID because we know the account ID. User identity principal IP. I don't think we really need that because we already have it in our user identity ARN. This would be helpful though. We have our this long thing. I think that would be a helpful thing to include in our field. So I'm going to add that. Principal ID. That seems similar to what I already have, but let's go ahead and grab it. And maybe, oh, user identity type, that's going to be helpful too. Geez, I'm going to have a bunch of fields. And maybe the session issuer username. No, I think we already have the username covered by like this right here. Okay. Let's begin with that information. I'm going to close out some of these fields. And now you can see we have, let me throw this to the side. You can see, we can easily see some of these fields now. So we have our time, our source IP address, our user agent, our access key ID, our ARN, our event type, our event name, and the user identity session that is doing it, which I guess kind of correlates with this pretty well. We'll keep it just in the chance that we need it. And the other thing I like to do is sort this by descending so we can see kind of the time frame as things are working. All right, now that I have that set up, let me look over at chat, make sure I'm not missing anything on chat on the different platforms. And I don't think I am. Okay, cool. We'll keep on working through this, and I'll keep stumbling my way through what is going on. So if we look at our hits here, we could, if we look at this, we have a count of 18 here, and then we have a spike of activity. You see that in the 10 minutes? So that stands out to me a little bit. Let's go ahead and grab this spike of activity and see if we can investigate what might be going on here. So once again, we have interesting stuff here. We have no activity, like everything seems normal. But if we go back to our scenario, it says we notice unusually high CPU usage on an EC2 instance. I wonder if any of this correlates to the EC2 information. We can just kind of begin to walk our way through this and see if we can figure out what is going on. I want to start, I think, let's start right here. And if we glance at this, just seeing what is all going on, can I see here? I think I'm missing a field that might tell us whether or not things are erroring out. Is there one that says whether or not the request succeeded or failed? Am I blind? TLS true AWS API call describe organization. Oh, access denied, error code. I want to be able to see the error code as well because we want to see if whatever is going on is failing or succeeding, because that will give us a good idea of, maybe a brute force attack if we see a lot of requests failing. All right, now we can close that out. So where is my error code? Error code over here. Can I move it to the left, to the left, to the left? And also user identity type. Let's move this. Okay. So now we can begin to investigate a little bit what was going on. We have this data here, and right away what catches my eye is we have an access denied error on trying to describe the organization. So it seems like some enumeration. We have a get caller identity, which I believe what this command here is AWS STS get caller identity. Now, if you're new to Linux, I can just show this to you in a terminal. In Linux, it's who am I, right? That's how you figure out your role. Well, in AWS, because it's AWS and it has to be more confusing, in order to, actually, one second, let me deal with something on Twitch. Apple Juice, what are you posting, my friend? Apple Juice posted some weird URL. I'm going to assume that's not spam, but don't post silly URLs or else I'll have to kick you from the Twitch chat. Anyways, in Linux, we can do who am I to see our role. Oh, just kidding. Okay, cool. I wanted to make sure you were just messing around. That's fine. I don't even know what the link is, dude. Some weird, silly URL. All right. Who am I, Tyler? And then in order to do the same command in AWS to figure out your privileges, it's AWS STS get caller identity, and then you pass it the profile that you're using. So like if we were Hack Smarter, we would pass it our profile, and you can actually see from when I was doing a different lab and I named my profile Hack Smarter, I still have access to that AWS environment. But you can see that's how you do a who am I in AWS. So one thing to look for if you are doing threat hunting in an AWS environment is seeing, hey, is there an account that keeps calling this command? Because if there is an account that's calling this command, they might be trying to figure out who they are and what their privileges are. Because when I'm doing a lab or even a pen test, as soon as I get access to a new AWS identity, this is one of the first things I do. Additionally, there's tools like Paku, there's tools like CloudFox that will try to automatically enumerate roles and permissions, and you'll see a bunch of failed requests if you're looking at the logs, which I think might be what we are seeing here. Because we have this describe organization, we have get caller identity, which succeeded because it would. You don't need any special permissions to do that, but they're doing that from a role called web prod EC2 role. So that might be a smoking gun right there, so to speak. Let me grab a screenshot of some of this information, and we'll kind of point out some of the things that might be helpful. I'm going to grab that. We'll jump over to, if I do it from in here, there we go. Why? I had this issue last time. Notion wouldn't take my screenshots. It's like it's not going to my... All right, we're going to fix this real quick. Oh, okay. How about light shot? Okay, no, there's what's the alternative on Linux, y'all? Is it I'm just going to download it to my actual VM so I don't have to use my host computer because it seems to bug out. Best light shot alternative. Isn't there like green shot or something? No, is it fire shot? Isn't that an alcohol? Flame shot. Flame shot. There we go. All right. Let me see if I can just get this installed real quick. It'll make our screenshot process easier. Flame Shot is very similar to Light Shot, I believe. Okay, can I set up configuration, shortcuts? The frick, how do I, where's the screenshot shortcut? That's all I need. Delete current tool, accept the capture. Flameshot GUI is the shortcut? What do you mean by that? I want it to automatically do it when I hit a key. Well, maybe, oops, set pencil. Okay, I'll just click it. That's fine. That works fine. I'll figure it out later. Oh, run Flameshot GUI and that will open the screenshot utility. That is the custom command that you enter. Well, can I set it to my keyboard? Oh well, I'll figure it out later. Let's not get distracted by my obsession with certain screenshot tools. And we'll just click there. That'll work just fine. And we'll grab some of the information that stands out to me like this. And we can use our little box and I'll highlight a few things here. One is the source IP address. We might want to dig into this and see, hey, where's the source IP address coming from? We have our user identity access key ID, so we know this is the user that they may have compromised. User agent might also be interesting, something we might want to dig into. We have the ARN. We see the commands that they're doing, describe organization and get caller identity. The access denied tells me they're trying to brute force and figure out what privileges they might have. And finally, we have this web prod EC2 role, and we know in our scenario, there, thank you. We know in our scenario we're dealing with a possible EC2 usage. So we can just go ahead and jot down some of this information. So we have source IP address, right? And we'll just do code here. Oh, let's do the whole thing code because it looks nicer. We'll just go like this. Do source IP is 173.244.55.135. Whoops. Like that. That's the main thing. We don't need to jot down our access key ID, but the other information we might want to get is, we'll just call it username. That's basically what that is in AWS. It's web prod EC2 role. And now keeping in mind that we are dealing with a possible EC2 that was compromised, this seems to match up some of the information that we have. So let's go ahead and see if there's anything interesting about this IP address. We'll just do like IP reputation check. I know there's a bunch of different tools that can do it. And we'll drop it in here and see what information we can find. Hey, you're looking at YouTube. What is up? Christopher Whitlock, good to have you here. Jeffrey Allen said, what's up, Tyler Moore, Pwned Labs? Yep, yesterday we did some Portswigger and Try Hack Me, and today we're back to some Pwned Labs. So this is interesting. It's in Venezuela, which unless the company does business there, that would be suspicious IP. Now, we don't have anything saying, hey, there's issues wrong with this, but we do need to keep in mind it's a lab environment. So if they're trying to emulate a threat actor from a different country, they probably just jumped on a VPN and did this. And so the IP itself may not seem to be malicious, but if our company does not do business here, well, we probably shouldn't be having IPs from a whole nother country trying to access our AWS environment. So of course, it's company specific, but if we just assume we are a US-based company, why is someone from Venezuela logging into our AWS account? So that is a little bit suspicious. We can go ahead and grab a screenshot of that. We'll just go like that for the IP information. And whoops, we'll jump over to our notes. And this is one request I have. If anyone is watching from the Notion team, can you please just align my images to the left? And also, I wanted to make this H2. There we go. So we have our source IP address, we have our username, and now we can actually begin to filter some things. I think, let me just first see if my hunch is correct. Was this where we're at? Elastic. Let's look through some more of what this user is trying to do. They all seem to be coming, oh, they're not all from this IP address, but they are from this IP address range. We have 135, 132, 135, 134, 133, 134, 133, 134, 133, 134, 132. So the IP addresses are changing a little bit. I think we can filter maybe based on that these 3 digits there. But let's see what they're doing. They're all using this same WebProb EC2 account, and it sure does look like they're trying to brute force the permissions that they have. We see all these commands happening almost simultaneously, which tells me they're using a tool like CloudFlux or Paku or AWS Enumerator, I think is another tool that basically just brute forces all of the AWS API to see what permissions, what privileges do I have. Maybe the closest equivalent for something like this in Windows or in Linux, we'll do Linux. I know many of you are familiar with doing a CTF in Linux, but would be something like linpiece. Now, linpiece is a little bit different, but it is an automatic enumeration tool that says, hey, what permissions do I have on this box? What are some ways I might elevate my privileges? Well, that's what some of these other tools do as well, just in the cloud world. But because they're sending all of these API commands, any good blue team or SOC who is watching the logs and looking at alerts, this should trigger alert that someone might be brute forcing permissions because we have all of these access denied on common things. Like we're trying to list a bunch of services, get APIs, get REST APIs, and just access denied, access denied, access denied. So they seem to be trying to go through there. Let's go ahead and back out. Well, actually, let's filter. We can filter by, let's do maybe source IP address first. And can I modify this some? If I edit the filter and I do that, will that include, how do I do a wildcard? How about contains? No. 173.244.55. Will that just work? Let me check. Is not an IP string literal? Okay, there has to be a way for me to modify this. Is one of, is not one of, is between. What if I do 173.244.55.0? Let's just do that. That should get it, right? There, cool. Now we'll just go and get all of those IPs that might be in that range. I know there's probably a better way to do it, but that's the way I'm doing it my way. And it seems to work. So now we're limited to just the IPs coming from Venezuela and in that IP range. And now if we back out, oh, that's going to mess up my filter. Okay, let me just reset our time. I think it was just like 00. Oh, turn on numlock. We'll go there, and we'll go to this one, and we'll just say now. Let's just back up here. Whoops, no, I said now, dude. All right, there's probably a better way to do this as well. But now we have 5,000 hits, and we can look at some of our information here. So we still have this count right here, which seems to have a lot going on. And let's honestly just look through this. We're getting access denied constantly, so I think that does confirm we're seeing some type of brute force attack. I'm just going to scroll way down, way down, way down. Yeah, access denied, access denied. What if we jump? So we look at some of these patterns here. Like, what if we go to this one right here? We're still getting access denied. You know what? One way that we could filter this out is if we back to here. What if we filter out access denied We'll go like this, which will filter out the value. So we'll say only give values where it is not access denied, because I think we can confirm right now the attacker is brute forcing our AWS account, but we want to ask the question, did they get access? And if so, how did they get access? So we don't need to see access denied over and over again. So we're going to filter out that value. And that lowers it to 155 hits. So that will be helpful. Let me get a drink. So now that we're lowered to 155 hits, let's see if we can continue to investigate and figure out what is going on. So we have this get caller identity. Remember, that is at AWS STS get caller identity profile hack smarter, whatever their profile is. This would be like the EC2, but that's the profile there. Z Lodi said, hello from Ukraine. Wow, super cool having someone join from Ukraine. And I'm a huge supporter of Ukraine. So, man, so sorry for everything you guys have gone through. But I hope Russia gets out of your country, sincerely. And thank you for joining me on stream. Appreciate having you here. All right, let's look through some of the successful things here. So we have describe regions. We have another error here, client unauthorized operation. Let's filter out that value as well. That's just another error. And so, did they successfully describe applications? Are they getting somewhere here? Let's see if I can look at the raw JSON and see what's going on here. Don't even know if this is helpful, but no, nothing's really standing out to me. But more enumeration, but from what I can tell, some successful enumeration in the AWS environment. Let's keep scrolling down. Oh, and we're listing functions. Hold up. So are we listing Lambda functions now? So with Lambda functions, you can often find some sensitive information in the Lambda function in the environmental variables. Matter of fact, I demonstrated this exact thing on my most recent Pwned Labs walkthrough. I think I released it on Monday, but with CloudFox wiki environment Lambda, I'm just going to type that. But there's an nvar, I think it's n. Oh, jeez. Jeez, I can't find it. You guys just have to take my word for it. Oh, there it is. If you run this command in CloudFox, what it will do is it will grab the environmental variables from services that have them. App Runner, ECS, Lambda, Lightsail containers, SageMaker are supported. And what often happens, I even see this when I do real AWS pen test, is you will see organizations store sensitive values in the Lambda environmental variables. And often those sensitive values are access keys and secrets, which would provide an attacker with more access to the AWS environment. Now, if you're new to AWS, let me just share a little bit about what I'm talking about. An access key ID is sort of like the username. That's public information. An access key ID, you're not going to be able to compromise someone just with that, but an access key ID also has a corresponding secret, which is sort of like the password, hence the name secret. You don't want people to gain access to it. If I get access to your access key ID and your secret, well, now I have access as you on the AWS command line interface, and I can pivot deeper into your environment. So as an attacker or a pen tester, that's something I check all the time. Is the organization storing sensitive values in the environmental variables that anyone with access, read access to the Lambda function, are able to gain access to, and then elevate their privileges. Yo, we got DJ BSec. What up, dude? Good to have you here. Yeah, we're changing it up. Usually I'm showcasing hacking stuff, but in today's stream, we're showcasing threat hunting in the cloud, showing off some AWS threat hunting type stuff, and we're hunting down an attacker who has compromised our web prod EC2 role in AWS. But I think that's what's going on here, that they are listing functions. Can we see any more data? If I go this here, do we have any information about the functions they're trying to hit? Okay, we don't yet. Let's keep following this threat actor. What are they attempting to do? They're listing functions, listing functions, listing functions, listing functions. They really like to list these functions. Once again, probably an automated tool that's doing this. Resource not found exception. Okay. Well, that's interesting. Let's jump back out and we'll just reset this. For those of you who know ELK Stack better than me, tell me if there's an easier way for me to return to like my previous view, because this is always annoying in ELK Stack. I'm gonna click this. All right, now what I want to look at is we have a lot of activity right here at 9:30. So let's go ahead and click in here at 9:30. DJ B6 said, working on music and saw Tyler was live. Cool, man. Well, thank you for welcome to the party, pal. If I copy Simply Cyber, good to have you here. I don't have the cool sound effects so like Jerry does. I don't know how he does that. I only have OBS. I don't have all this fancy software. I have to make my own sound effects here in the OBS world. All right, let's continue to look through here. Oh, wow, they're doing a lot. Oh, wait, they compromised another user. Oh, they compromised Noah. Noah's been compromised. When did that happen? Let's go right here. Noah got compromised, ladies and gentlemen. Oh, no, and now they're logging in as an IM user. What user are they logging in as? It doesn't tell me. This isn't good. Noah. They logged in as Noah. Let's figure out when this happened. If I back up, here, let me back all the way up. So I want to see where it changes from WebProp EC2 to something else. But Noah has been compromised, ladies and gentlemen. Scrolling. Oh. I think it was in the Lambda function. Whoops, kind of like what I was saying. Because we see our threat actor here from Venezuela, according to his IP address, listing functions from the WebProd EC2 role, and then what we're doing after that is, we compromise a shipping data user. You guys catch that? So if we look back at right here, we are listing our functions. Right here, listing functions. So they're apparently getting some data from a Lambda environmental variables. Can I see what they're targeting? And I'm probably doing this wrong. Like I said, I don't do blue team stuff generally. Actually, almost never. So there's probably a better way to do this, but this is the Tyler way of learning it as we go. So it doesn't show us there. But now I'm just curious. If I scroll up. All right. Well, I think it's safe to say because they're listing functions and then they switch the user over to a shipping data user. Let's go ahead and grab a screenshot of this for our notes as we work our way on this incident. We will grab, let me see what, I think it's right here. Maybe we'll grab that. And so here's what stands out to me. We have our WebProd EC2 user listing functions. All right. And then they're doing get caller identity on their own role. But then all of a sudden, moments later, I should probably include a timestamp. Can I drag? Oh, no. Okay. Let me do a screenshot again. We should include the timestamp if we're doing log analysis here. But we have them. If we look at the timestamp, at 9:20, they are digging into some Lambda functions from what I can tell. So our compromised user right here is digging into Lambda functions. Or at 9:09. And then less than a minute later, or maybe about a minute later, we have that user from a similar IP address, not the exact same IP address, but the same range there, logging in as another user called shipping data. I would say they found some credentials in Lambda environmental variables that gave them access as the shipping data user. That is my guess at what is going on here. Let's go ahead and drop this information here. We'll say movement from EC2 to shipping data user via lambda variables. DJ BSEC said, yeah, I was going to say different IPs, but same subnet. Yeah, and they're all from Venezuela, which is odd, which tells me, hey, they might be using a proxy of some sort. They're changing their IP based on call, which is actually really possible. The coolest pen testing organization around, aka Rhino Security Labs, where I work, we actually developed an official burp extension called IP Rotate that does this on web requests. So this actually comes from my team at Rhino. But this extension spins up API gateways in AWS. And then when you're doing a web app pen test, and let's say they block you by your IP, or they're trying to trace you by IP, what this will do is it will do every single request through Burp Suite, but from a different IP that you have spun up. So this seems similar of what I see going on here is, of course, not a web app, but they might be doing something similar with a proxy or some API gateways so that they're changing their IP on each request. Which is why we did, instead of locating one IP, we did a range of IP. So I'm telling y'all, blue team and red team go together. I'm a pen tester. I don't do any of this blue team stuff for my job. But to be a good pen tester, you need to understand blue team because you need to know how to evade some defenses. But to be a good blue teamer, you need to know how to think like a hacker. Like my pen testing experience allows me to see, okay, this is probably what they're doing with their IPs. It doesn't throw me off because I do the same thing in my own role. When I put on my black hat, not truly, I'm not a criminal, but when I put on my pen testing hat, I'm doing something similar. But yeah, this is pretty obvious. They're doing it all really quick. They've compromised our user shipping data. I added it to my notes, right? Moving from EC2 to shipping data user via lambda variables. And then at some point in time, they compromise the ARC and they become Noah. Let's see what's going on here. If we scroll through here, we have shipping data. Actually, what are they even doing on shipping data? I'm curious. So they become our shipping data user, and they're doing the get caller identity, the standard who am I in AWS. They're trying to list accounts. They're trying to describe endpoints. And now they're just apparently doing the wrong syntax. They're listing users, so this definitely seems like they're trying to enumerate the environment. Oh, shoot, they're listing secrets? They must have access to Secret Manager then? That's not good. They compromised a privileged shipping data account. Yeah, so they're accessing Secrets Manager. Now, once again, if you're new to the AWS world, Secrets Manager is kind of like password storage, blanking on the word. You know, when you have the third-party password management tool, why am I blanking on what that is? But anyways, that's kind of what Secrets Manager is in AWS. It's where you're supposed to store your sensitive credentials, and then when you have like a Lambda function, you should reference them there so that you're not storing the password or the sensitive key in clear text. Instead, it's coming from Secrets Manager when it runs. But this account that our threat actor has compromised, yeah, Key Vault, thank you guys over in chat. The account that this threat actor has compromised must have permissions to Secrets Manager, and they're able to list secrets. And I almost guarantee what we're going to see them do next is pivot to that Noah user. Yeah, because look, they're getting a session token, they're getting caller identity, they're listing more users from shipping data, get secret value. Yeah, they're grabbing all the secrets right here, and now we have these console logins. And that's just setting it up so they have permissions to log in via the AWS console. I bet if we scroll through here, and there we have Noah, right? There's Noah's compromised right there. So let's go back up here, and just as we continue to document this, if we were doing an actual report for our team, we have pretty clear evidence of how they compromised the Noah user. So let's grab a screenshot of that right here. Movement from shipping user to Noah via Secrets Manager. I meant to make that H1. And so we have that in our notes. DJ BSEC said, looks like they're using WSL as well. Yeah, good call. You can see that in the user agent, Windows subsystem for Linux. Right there. So let's scroll down. We have Noah being compromised. Whoops. Right there. So we should probably take a screenshot of that. We have an AWS console sign in as the Noah user. So let's grab that screenshot. And we'll just drop that in that same section because it kind of goes with it. Right, there's our Noah user who has just been compromised. And yeah, there's Noah again from an IP, very similar IP. You can see the person's just rotating IP, but just the last part of it. So they're not even trying to hide their checks very well. But they log into the console. You can see we have the Mozilla Firefox as our user agent now because they're logged into the actual AWS console. They're no longer working from the command line interface. They're going from the console itself, and they're logged in as the Noah user. And geez, Noah seems to have quite a few permissions because you can notice, if you remember up above, this is the field for errors. So, hey, if there's an error, if we're not able to do it successfully, it's going to fail right there, but there's not too many failures going on. What up, Raw Clicks? Raw Clicks said, I'm taking a break from Hack the Box and just explore the science and tech category. Dude! All right, I'm going to copy Simply Cyber again. Welcome to the party, pal. It is good to have you hanging out. Just so you know, my main platform is YouTube. I stream live on Twitch and LinkedIn and YouTube. But if you want to catch all my videos, you can find them on YouTube, always coming out with content. And if you enjoy Hack the Box, you'll probably enjoy the rest of my channel. I am a pen tester for my day job, and most of my content I make is on pen testing, offensive security, working through machines, and also shorter videos showing some technical perspectives on things. So I just dropped my link over on Twitch, but Raw Clicks, yo, come join me on YouTube. Would love to have you there, but Twitch is good as well. You just can't catch any of my past videos on Twitch. All of them are on YouTube, so that is the place to hang out if you want to catch some of the past content. But Raw Clicks, thanks for dropping in. Glad you stumbled across my channel. All right, back to our threat hunting. We have Noah at hugelogistics.com. Rockclick said, I've around 4 years as a security consultant, but mostly blue team training for pen testing. Now, dude, then my channel would be perfect for you. That you're who the channel is for. I also have a Discord, and let me drop our website. We have an entire community, my friend, dedicated to helping people with career growth. And I just dropped a link. Hacksmarter.org has all of our information. Here's what probably separates me from almost every other YouTuber content creator you found. I'm not in it for the money. I mean that seriously. I do one-on-one coaching for people. We have an entire team that does one-on-one career coaching for people, but we don't charge you anything. Instead, just donate what you can. We just ask you to donate to a nonprofit of your choice, and then we sit down and work on anything you want to work on. It could be, hey, resumes, a mock interview, just a career plan for your career. Everything that we do in the Hacksmarter community is free of charge. Nothing at all is behind a paywall. Our goal is not to make money off the community. We are good enough at what we actually do as pen testers and in cybersecurity that we don't need to charge other people. So, hey, if that sounds interesting to you, join us on the movement, but hacksmarter.org. DJ BSEC said, what's your name on Twitch? My name on Twitch, here, I'll drop it over on YouTube, but it's hack_smarter. You can find me on Hack Smarter on the Twitch side of things. Rockclick said, just drop the sub on YouTube. Sweet, man. Thank you for the sub. Appreciate you being here. All right, back into our threat hunting. Actually need a drink of water. Too much talking. All right, back into our threat hunting. We have our Noah user who has been compromised. They're logged into the AWS console. And like I was saying before, it seems like they have a lot of permissions because you can see they're describing hosts. That might be EC2s, things like that. Alarms, volume, snapshots, addresses, instances. This is not good. They are succeeding on everything that they are describing. This is a very much a privileged user. Let's scroll through and see what Noah ends up doing. Kind of following our cyber kill chain. We'll just keep on scrolling. Dang, Noah's killing it. Oh, what just happened? We see a change of user. I think I know what happened here. We're describing addresses, then we're describing instance attributes, then we're describing instance status, and notice right after that, we're switching to what appears to be an admin role, Jenkins admin policy. Now in AWS, there's EC2s are what they call virtual machines, all right? Now, I shared before, AWS likes to be confusing on purpose. And so instead of using like a typical name like a virtual machine, they call it an EC2, which is just a virtual machine. But EC2s have something called user data. And we'll just say like exploit would probably be one thing that we can do. So user data in EC2 are like scripts that run when the machine is set up or when the machine launches. So if it's not configured properly, what organizations will sometimes do is they'll store sensitive data. This person's using it actually for command execution, but they'll store sensitive data in their user data field on the EC2. How amazing. I'm looking up research, and you got the one and only Tyler Ramsbey talking about EC2. But let's look at EC2 privilege escalation. I have videos that cover this. So here's one way you can do it, and I have videos demonstrating this. You can use the EC2 for privilege escalation, but what can also be stored in this user data field are credentials for other users, which seems to be what possibly happened here. Because immediately after describing the instances or the EC2s or the virtual machines in the AWS environment, they pivot to the Jenkins user, and I honestly think that's probably game over. Let me grab a screenshot of that. And we'll do that. From Noah to Jenkins admin. Game over. All right. Let's continue to follow this threat actor. Once they get access to the Jenkins admin policy, they're doing that get caller identity again. Once again, for those of you who may have joined beforehand, this is just the who am I in AWS. It's AWS STS get caller identity profile. Freaking confusing. Jenkins. They're listing apps or getting REST APIs or getting account, getting usage plans, getting domain names, getting API keys, getting client certificates. This is bad, y'all. Like, this is full compromise of the AWS account. List backup plans, list work groups, describe environments, describe launch things. Oh my goodness. This is not good. When does it end? Wow. Can I jump to the last? Oh my, and then it's game over. I'll let you guys look at this. When I say it's game over, see if you can figure out why it's game over. Our user, once they compromise the Jenkins admin, boom, stop logging. They have full admin permissions to our AWS environment. They elevated their privileges from an EC2 all the way up to a Jenkins admin user who seems to have like full admin rights on the AWS account, and they go all the way to stop logging. From here, they probably set up some crazy persistence. So if we look at our initial scenario was we noticed unusually high CPU usage on the EC2 instance. No, bruh, it's way worse than that. Your entire AWS environment has been pwned. We have t-shirts at Rhino. Our Paku I think it's our Paku t-shirts. I don't have one on right now. I have them up in my closet. But on the back of it, it says, my other computer is your AWS account or your AWS EC2. That's what this reminds me of. My other computer is your entire AWS account. This threat actor fully pwned them. So let's walk through our steps. Our threat actor somehow, some way, we don't know how for sure, but because it was a web server, maybe they use SSRF, maybe they had EC2, maybe they had command injection, but somehow, some way, they got access to a user role that had the web prod EC2 role attached to it. All right? We noticed that we had a suspicious IP. From there, it seemed that they used some automated tool because we had a lot of failed requests. Maybe they were using Paku, maybe they were using CloudFox, something else, but they had some automated requests here trying to figure out privileges, and they seem to have checked the Lambda functions, and which is like serverless functions in AWS. But in Lambda functions, you have environmental variables that if the environmental variables are misconfigured, they will store sensitive data, their API keys, access keys, secrets, and this is real world, y'all. I do AWS pen testing. I see this all the time in client environments where they're storing this exact thing in a Lambda function. So that's what our threat actor finds. From there, they get access to another user called shipping data. From the shipping data user, they realize that they have access to Secrets Manager. Now, Secrets Manager in AWS, you don't want to give anyone access to it because they can give access to really detailed secrets. As the name says, this is where you store your stuff that you don't want people to see. Well, this user, shipping data, has access to Secrets Manager. And from what we can see from Secrets Manager is they open up Secrets Manager. Whoops. Let me scroll back down. They open up Secrets Manager, and within Secrets Manager, they find another user called Noah at hugelogistics.com. From Noah at hugelogistics.com, they actually log into the AWS console, and then while they are on the AWS console, they look at EC2 user data based on what I can see here. And in the EC2 user data, they somehow find credentials for our Jenkins admin policy, and then Jenkins admin policy stops logging, turns off log data, and fully compromises our environment. Boom. Nice Opinion says, was all this just from misconfigured permissions? Absolutely. That's what you'll notice in cloud, y'all. Cloud is so massive, so big, and there's so many people who have their hands in cloud. It's kind of like Active Directory, that it's easy to have things misconfigured. It's easy to believe in the principle of least privilege. It's a lot harder to implement it in practice. And what we see here, once again, is real world. I see this pretty often in real customer environments when I'm doing pen tests in AWS infrastructure. So this isn't some like crazy CTF. This is real world misconfiguration that you are seeing here. DJ B-Sec said, game set mesh, now you can't see what I'm doing. Exactly. Time to drop some crypto mining, which seems to be what they did because our scenario said they had high usage on an EC2. Well, yeah, bro, because all of your EC2s are doing crypto mining for the threat actor. And if you kick them out, they probably already set up persistence in your environment. It really is game over. Bro, that was a fun lab. Now, once again, guys, if you have not checked out pwnlabs.io, you tell me, is there any other platform anywhere that offers this quality of cloud security training? Now, you've seen me do the red team labs. This is a blue team lab. There's nowhere else that offers this quality of realistic cloud security training at the price. You can get a full premium subscription to Pwned Labs for $200 a year. That's crazy affordable. Like, for perspective, Hack the Box has some similar stuff, but for Hack the Box, you have to have an enterprise license, which I think is in the $10,000 range just to get access to the cloud training. Try Hack Me has some stuff, but it's more just like teaching how to use AWS. And for that, I think you're looking at $300 to $400 for temporary access. Pwned Labs, y'all, $200 for a year, full premium access. Outside of that, there's 30 completely free labs. So you can check it out. 30 labs that you can do without even signing up to get a feel for it. Amazing. All right. I'll get off my soapbox, y'all. Cyber Warrior said, Tyler, when do you sleep? Every once in a while I sleep. Occasionally. I'm just hyped up on caffeine all the time, if you can't tell. Caffeine and my warm apple pie candle burning over there. All right, let's look through this walkthrough. The cool thing about Pwned Labs is if you're brand new to cloud, they have detailed walkthroughs for everything. DJ B-Sec said, is this Azure, AWS, and GCP? Yeah. Let me just show off Pwned Labs real quick, y'all, before I even close the video. I'm going to show you guys how cool this is. You can see we have a lot of free labs, but we have AWS, GCP, and Azure. And we can also sort it by red team or blue team. So if I just switch it to Azure, we have all these labs for Azure, and they're adding more all the time. If we switch it to AWS, we have all these labs for AWS. I can load more labs. And you can see we have quite a few free labs. You don't have to configure anything on your end. It's all configured in the cloud for you. Think of kind of like try Hack Me, Hack the Box. You just hit start pwning, launch the lab. It gives you your initial entry point, and then you get to work. And we have GCP, which I've done like nothing with GCP. I need to do some of these labs. But the cool thing about Pwned Labs is they are adding labs all the time. And I shared before, this month, they're coming out with Thunderdome, which is a red team pen testing lab with 9 different flags that requires you to compromise AWS, GCP, and Azure in a very realistic environment. I do have early access to Thunderdome. I'm kind of doing some QA and testing for Pwned Labs, and I can tell you, yo, it's one of the coolest cloud environments I have seen for learning this stuff. So check out Pwned Labs. It is an amazing platform. But back to our current lab, let's look at the walkthrough. Oh, DJ B6 said, who is Pwned Labs? This is amazing. I'm going to push this in the AM with Jerry. Dude, push it. Tell him all about it. Pwnlabs.io. I technically work part-time for Pwnlabs.io, full disclosure, but I don't get paid anything. So I don't know if you call that a job or not. I just started streaming their content because I thought the platform was incredible, like this hidden gem. It's really new as well, but incredible quality platform. So I just started streaming it on my own, like on YouTube. And Ian Austin, who is the founder of Pwned Labs, just reached out to me. He was like, dude, do you want to join us on a more formal basis? And I said, yeah, but like, you don't need to pay me. I want you guys to succeed. You don't need to waste your money paying me. I'm going to make the content whether or not you pay me or not. And so they added me to their team as a content creator, but I don't get paid anything. So when I'm like raving about Pwned Labs, guys, I don't get any kickbacks by you signing up. I don't get any money back by you signing up. I really do think it's an incredible platform. And the reason I am a formal employee is because I had to sign an NDA so that I have access to all the labs before they come out, so that I can QA them before the rest of you see them. And same with Thunderdome. So I can QA that full lab before you see it. So I had to sign an NDA. So that's one of the reasons I'm considered an employee of Pwned Labs, but I am a volunteer employee of Pwned Labs. It's incredible, guys. Check it out. You'll enjoy it. All right. Now that my commercial is over, let's see the official walkthrough for this and see if my idea was correct. America said how much? So you maybe just joined, but America, I'll say it one last time. Pwned Labs has a bunch of free labs. I think over 30 free labs. If you want a premium subscription, it's $200 a year is what it costs. Cyber Warrior said, I love Tyler. He's one of the few guys that isn't just saying stuff to make a quick buck. One of the true gems on here. Thank you, my friend. Yeah, I appreciate it. And you guys will notice I don't do like sponsored content on my channel. I talk about a lot of platforms. I'll talk about Pwned Labs, Try Hack Me, Hack the Box, but I don't talk about it because they pay me, because to be honest, they don't pay me. I talk about them because I really enjoy their platforms. I think thank you, Windows Defender. I think the tough thing about a lot of YouTubers is they have so much sponsored content, you don't actually know what they use or what they believe in. Like, if you pay people enough money, they'll make videos for you. If I make a video about a platform, you know that it's not because the platform's throwing me money, because they're not throwing me money. Even with Pwned Labs, I showed you before, they said, let's partner formally. And I said, yes, but don't pay me. I don't want your money. I want your platform to succeed. Let me just promote it for free. Jay said, anyone else get issues connected to the VPN from Pwned Labs? Hey, Jay, that was an issue, but it should be fully fixed now. If you're still having issues, drop it in the Pwned Labs Discord or DM me personally and I'll follow up. But there was a VPN issue. It should be fully resolved now, Jay. Okay. Back to this. This is kind of what I did in the beginning of the lab. Remember, I set up my table so we could analyze things better. I'm going to kind of skim through here. I want to see if I followed everything properly. Like, the way you approach this lab could be different. I bet I did different columns than the official walkthrough, but we got to the same end goal. And here's something DJ BSEC pointed out, is that the request is executed using the AWS CLI on WSL Windows subsystem for Linux. And so DJ BSEC gets credit for noticing that in the user agent. And then we have this web prod role that we saw before. We have the source IP, so they did IP info. That's a cooler hacker way of doing it. But we do see it's in Venezuela. But the IP does change, but it seems like the overall IP doesn't change. Just the last octet. Okay, yep, they noticed the brute force as well. They're brute forcing IAM permissions. Oh, and so apparently that user agent, this Go user agent, is connected to CloudFox. Just did a video, guys, on YouTube where I give a full walkthrough of how to use CloudFox. So check it out. CloudFox is a cool tool, but that seems to be what our threat actor is actually doing. The tool is getting information from a Lambda instance. I was right. And yeah, CloudFox is exactly what I was talking about they might use. They got it from a function named shipping data. And so what can Lambda functions do? Well, they could download the function source code and see business logic and hard-coded creds. They could retrieve any environmental variables that are configured, which is what I talked about. They configured the Lambda function to use a more privileged identity, and they can leverage a vulnerability in Lambda function to execute commands in the context of the Lambda role. Oh, DJ BSEC, does everyone know what IAM is? Good call. I should explain that. Identity Access Management. Yeah, IAM in AWS, well, IAM is used in all the cloud services. It's just like your username, essentially. Like, IAM management is managing users, roles, and permissions. That's my ELI 5 explanation of it. So after the list functions, we see a get caller identity showing shipping data. So we were spot on. If I look at my notes, I said they moved from EC2 to shipping data using Lambda variables, and yep, that's exactly what they did. So track that threat actor down in that move. And then we see list users. Oh, they're using AWS enumerator. It's kind of a brute forcing tool for IAM permissions. So once again, to define what's going on here, they're just saying, hey, can my user access secrets manager? Can my user access virtual machines? Can my user access policies? And these tools just brute force the API over and over again to see what access we have. But because it's brute forcing over and over again, if you're paying attention to logs, this is a super obvious attack, not sneaky at all if the SOC is paying attention here. Which they must not have been in this environment because they got totally pwned. Maybe that happened like during a skeleton crew on Christmas or something when threat actors like to kick it in high gear. We filter in on requests from shipping data. I didn't do that. I filtered on IP. Although we could filter on the IP address, we see they're probably using a VPN. It does change dynamically, but only the last octet. So although you actually can filter on IP, which I thought was helpful, you just have to do a range, which is what I did. I did an IP range on what I was filtering in on. DJ BSEC said, also, if you are brute forcing, it seems like you don't have account lockout either. Well, similar. So it wouldn't really, I need a drink. It may be rate limiting, but there wouldn't be account lockout because brute forcing IAM permissions are not trying to log into another account. They're not brute forcing a username and password. They're just sending a bunch of like AWS get policy and trying to get a policy. AWS get caller identity. AWS list roles. AWS list users. So they're doing it from within their own account and they're kind of spamming the AWS API. But there should be some rate limiting in place or alerts that should be going off to, yes, slow them down or shut them down. But they're not trying to log into other accounts. They're not brute forcing passwords. So they're not necessarily locking accounts. They're only logging into other accounts once they find like a secret being stored somewhere, at least from what I can see. And yeah, we saw access denied, and I exited out. I filtered out the access denied. They used KQ query ourselves. I'm not lead enough to do that. I do it the script kiddie way of just like clicking GUI stuff. We enumerate permissions. The threat actor follows with AWS CLI. After listing IAM users, we see secret name shipping app. As they might have got user credits at this point, let's remove the filter for shipping data. Yep, so we found all that. Remember their secrets manager, so I was spot on there. They did secrets manager. That's when they compromised NOAA, I think. And yep, NOAA right there. Which they logged in via the console. Like sometimes the AWS CLI doesn't have MFA, but every user that can log into the AWS console, MFA should be enabled for everyone. So this is the importance of defense in depth, y'all. When we look at this from a blue team perspective, the more difficult you make it for the threat actor, you're going to stop them. And one of the easiest and best things you can do is just enabling MFA across the board. Matter of fact, I made a video about this week. I think I made a YouTube short about, hey, here's how to stop me from hacking you. Enable MFA. If you're relying on password authentication only, you're asking to get yourself pwned. So we have this NOAA account, which seems to be a privileged account that doesn't even have MFA enabled on his account, which allowed the threat actor to log in as the console as NOAA. Right? Misconfigurations. Hindsight's always 20/20. Yep, they access the EC2 service. And yep, I saw that as well. They have a user data field, so I was spot on when I called out the user data field that allows admins to run commands. This could be used to add a threat actor's public key to the authorized key file to trigger a reverse shell. However, even without permissions to the updated user data and reboot the EC2 instance, there may be existing commands there that, against best practice, contain credentials or even SSH keys. Which it is against best practice, but just saw this recently, so it does happen. A few minutes later, we see a new call to get caller identity for Jenkins admin policy attached to an EC2 instance. The threat actor managed to gain access to a Jenkins instance and query the instance metadata service on the EC2 to get credits that allow them to assume the role. And then, yeah, it's game over. That's my favorite part. Stop logging. Stop listening to me. Okay, the flag is the access key of the assume Jenkins admin policy user. Where is my stack? So this is our final flag. Let me just enter that in and we'll go through that. But let's get our credit for the lab. There we go. Scrolling. All right. Attack. Let's check out some of the offensive tooling. So after compromising an external web server, which is kind of what I said, maybe they used RCE or SSRF, but they assumed this role that was attached to the EC2 instance, they executed this command. Now, what is going on here? Oh, DJ B6 said KQL. I don't even know how to say that. Is that how you say it? Is great. That is what MS Azure uses to threat hunt. You get Jenkins and admin roles. It's good night, Sally. Yeah. I should look more into that. I know I did some KQL stuff when I was doing the Try Hack Me path on SOC 2. I just don't remember all of it. But let me explain what's going on here, because for those of you new to this, this probably doesn't make a lot of sense, but there is a metadata endpoint in EC2. So if I search like EC2 SSRF AWS, this is a good one. If you get RCE on a virtual machine that is in an AWS environment, you can often query what's called the metadata endpoint, this private IP, this 169, only accessible from the EC2. But from here, you can query through this, and you can actually get any roles that might be attached to the virtual machine by querying for latest metadata IAM security creds EC2 default. That's the name of the machine here, or the role, and you're able to get that output that we're seeing there. So that is what the threat actor is doing in their initial entry point. They have RCE or SSRF, and they're able to hit that endpoint and get that data returned to assume that role. Now, the information that's important here is we have the access key ID, we have the secret key, and we have the token. And the way you would configure that in AWS if you were the threat actor is we do AWS configure profile, we'll call it was it EC2 web or something? I'll just call it that. And it would ask us for our access key ID. We would type in the access key ID there. It would ask us for our secret access key. We type in the secret access key. Region doesn't really matter for now. And then we also need to do the session token. And the way you do the session token, there's a few different ways. I honestly always forget how to do it from the terminal. I always do it from Notepad. But you can do like nano, home, your username, AWS, and credentials, and then in there there's a spot to add the token. Otherwise, I think it's AWS configure set. Let me look it up real quick. Yeah, here it is. This is the syntax right there. So then for that session token that you see there, this is the syntax. So you would do AWS configure set AWS session token. You would paste in that long token, and you would specify your profile being EC2 web. And then, well, obviously that's not going to work in that syntax, but that's how you set that session token from the attacker point of view. And I actually do that on my previous video, so you can see me work my way through that. But that's why this information is so important. This provides us almost like a username, a password, and a token, or kind of like a JWT if you think of a web app. So with that information, we can authenticate as that user. And then they use that exact command I pointed out on CloudFox. I thought was really cool. On CloudFox, once you get that initial access, you can load that profile into CloudFox, and you run this envars command, and it will search all of that stuff to see if there's any variables being stored. And we can see that's exactly what happened. There's the Lambda service, the shipping data, and we have these being stored as environmental variables, a secret access key and an access key ID. But it's for that shipping data user. Hey, what's up, Joe Hudson? I'm glad your comment came up. Often on LinkedIn, the comments don't come up, but Joe Hudson just popped in on chat. Joe said, I watch you because it's obvious you're not just trying to get that money. Great energy, enthusiasm always, man. It's refreshing. Dude, thank you so much for the kind words. Really do appreciate you hanging out and being here and for the support. But let's see what happened here. So they moved to the shipping data user, and then there's that secrets manager, right? That's what I pointed out in my own investigation of what happened. They went from shipping user to Noah via secrets manager, and that's what we see going on here. They got access to Noah, or they just had a password. Ooh, so this is where they sprayed it. So DJ BSEC, they did do some password spraying here, but you'll see the reason it didn't lock out any accounts is they're not brute forcing, right? Password spraying is targeting different users, but with the same password. So it's not going to trigger that account lockout. Though once again, if you're looking at logs, you should catch this, but they found a password in Secrets Manager. They didn't know who the password was for, and they just sprayed all the users until they realized, oh, it works for Noah, and yep, he doesn't have MFA on. Another war on defense is, although Jenkins is important, probably didn't need the AWS manager. Yeah, Jenkins had full admin access. Remember the principle of least privilege on everything. Alerting should also be set up to catch IAM brute force activity. We kind of talked about this multiple times. That was pretty obvious looking at the logs. It's not advanced. It's not, nope. It's just like taking a hammer and hitting the door and no one's listening, so the threat actor gets in. More sophisticated threat actors will assume that alerting is already in place. And finally, instance metadata version 2 should be enabled on all EC2 instances where possible, as it requires authentication. So even with SSR vulnerability, the threat actor wouldn't have been able to get the attached IAM role. Yo. Amazing lab. Hey y'all, hope you enjoyed that lab. Hope you learned as much from it as I did. Like I said before, blue team definitely is not my strength. I am a pen tester, but even then I'm a noob at everything. I'm just stumbling my way through, trying to figure it all out and doing it live on stream and sharing my journey with you guys. But hey, hope you enjoyed this video. For those of you watching after the fact on YouTube, thank you for watching. And hey, I'll see you in the next one.